We're gonna be solving paper 1. Questions are applicable for both the core and the extended candidates. The topic is alkanes, and we're gonna be solving IGCSE organic chemistry questions, right? This one is gonna be for both. Let's get started. And before this, I'd like to tell you guys that pay attention to each question. If you don't understand anything, just feel free to ask in the comments below. And always remember one thing, that nothing comes without the work. You have to put in the effort and the work. So let's get started, right? Which statement describes methane? I know in half the video, or even in 1-2 minutes, you're gonna just like lose the attention span because of the reels we guys watch nowadays. But always remember that to get something big, you have to put in the hours. It's never gonna come without the hours. Okay, which statement describes methane? So we're talking about methane over here. Meth means you have one carbon atom, and ane means you have a alkane. Alkane means that there are only going to be carbon single bonds, no double bond over here. And one carbon means that you just have a carbon atom, one carbon atom that is attached to 4 hydrogen atoms, something like this. It is an alcohol. No, methane is going to be an alkane. It is an unsaturated molecule. Yeah, it's unsaturated. No, it's saturated, right? Unsaturation means that there's a carbon double bond. Sorry, it's going to be saturated. Saturation means that all carbon bonds are single. So the carbon atom over here, this carbon atom is fully saturated. Why is it saturated? Because look, saturation means you have the maximum number of bonds. If the carbon atom is saturated, like, it's gonna make the maximum number of bonds. Carbon can make 4 bonds since it has 4 valence electrons, right? So making 4 bonds in even ethane, in methane as well, it's making the maximum number of bonds. So it's saturated with hydrogens. But in unsaturation, it's not making the maximum number of bonds. So this methane is gonna be saturated. Next, it contains carbon, hydrogen, and oxygen. No, we're dealing with methane. Methane is just a carbon with 4 hydrogens attached, so there is no oxygen. Its molecule contains 4 single covalent bonds. Yeah, that's correct. How come there be 4 single covalent bonds? You can count it for yourself. 1 bond, 2 bond, 3 bond, and then that's the 4th bond. So there are 4 single covalent bonds in methane. Which equation represents the cracking of an alkane? Now you should know the conditions for cracking, and second, you should know what do we mean by cracking. Remember, there are large chain alkanes that have a lot of carbon atoms, but industrially we need the small ones to make plastics. To make polyethylene, what do you need? You need ethene, right? Ethene is just 2 carbon alkene, right? To make plastic, you need ethene. Polythene bags, the plastic bags, you need ethene, a small hydrocarbon, right? Ethene is this. So the demand for the small hydrocarbons is more than those for the large ones. So that's why we don't need the large ones. Since we need the small ones, what do? We crack the large ones into smaller ones. And once we're able to crack them and we're able to get the smaller ones, we're done, because that's what we need. Your petrol. What is petrol? Petrol is like, it's a smaller hydrocarbon. It's not a lot of hydrocarbons. You know why do they use the octane fuel? Oct means 8. Ane means alkane. So the octane fuel, the high octane that you get, is basically 8 carbon fuel. So it's not more than 8 or 7. The petrol thing is also not a lot of carbon. So that's what you need. That's why you crack the large ones. Now, next thing, you have to produce smaller ones. Let's see what we're doing. C2H4, there are 3 of it, and we're producing this. Now, what are we doing in the first one? From a smaller hydrocarbon, we're going towards a larger. No, we have to go from a larger towards a smaller. In the next one, you have C6H12, when adding hydrogen. No, we don't add hydrogen to it. What do? We crack it, and the conditions for it is, the conditions for cracking are, number 1, you need high temperature, right? You need a lot of temperature for it. Then you need a catalyst. It can be Al2O3, or it can be silica or some catalyst like this. So you need a catalyst. And then you need absence of oxygen. You cannot have oxygen in cracking. Why? Because if there is oxygen, remember, and hydrocarbon and oxygen, what are they going to do? It's going to combust. It's not going to crack, right? If you have oxygen, oxygen causes the combustion of things. So next is absence. For cracking, you need absence of oxygen. That's a must. So this one's not going to work. This one's not going to work. We don't need hydrogen. Over here, we're producing carbon. Is cracking there to produce carbon? We don't need coal out of it, right? We don't need soot out of it. We don't need simple carbon, right? What do we need? We need smaller hydrocarbons. So over here, we have a large hydrocarbon. That's an alkane, and that's hexane because there's 6 carbons in it. And then we're producing ethene from it. That's ethene because the general formula, you can see the hydrogens and carbon, they are in a 1:2. Why 1:2? Because hydrogen should be double of carbons in alkene. So this is an ethene because the hydrogens are double, right? You have to obey the general formula. Next you have C4H10. Again, that's an alkane. So and that's your butane. You also need to remember one more thing, and that thing is that when you're producing this the smaller chains, you have to make sure that the carbons on this side and this side of the equation are equal. And the second thing you have to see is that the hydrogens on this side and this side are equal. Let's see, we have 6 carbons on this side and we have 2 carbons here, plus we have 4 carbons over here. So there's 6 on the left and the right side. Now coming towards the hydrogens, we have 14 on this side, right? 14 hydrogens on this side, and then we have 4 over here plus 10. That's also 14. So you just have to make sure everything's balanced on both sides and you're going from a bigger to a smaller thing, not from a smaller to a bigger, right? Next, which statement about ethane is correct? It decolorizes bromine water. No. Remember that the bromine water test is for your alkenes, the ones that are going to have the double bond in them, that are going to be unsaturated. So there must be a carbon-carbon double bond in something. There must be a carbon-carbon double bond in something for it to decolorize bromine water. I'm going to show you how you decolorize bromine water. This is Br, okay? Right? This is Br2. And then you have C double bond C, H, 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 and H. Now what's going to happen is that this bromine right here, that's Br2, is brown or reddish brown or orange in color, whatever you like to call it. And this thing is colorless. This is an ethene that's colorless. What's going to happen is that when this bond is going to break and this bond is going to break, and then this bromine, let me give it a different color, red, is going to attach here to this carbon, and this bromine right here, let me also give it red color, is going to attach to this carbon. And this entire thing, this 1,2-dibromo or dibromo ethane, now it has converted into ethane, so it's a dibromo ethane, is going to be colorless. So initially the brown color is gone. Why? Because the Br bond has been broken. The brown color was only because of this bond. As soon as the bond got broken, the brown color disappeared, right? So that's how you go from brown to colorless, and you can only go it when you have a double bond, because that double bond breaks and the bromine gets added to both the carbons, right? So for ethane is an alkane, so it burns in excess oxygen to form water and carbon dioxide. That's correct. Any hydrocarbon, either it be an alkane or an alkene, even if it's alcohol or you're dealing with these kind of things, they're all gonna burn and give you water and carbon dioxide. So that's called the combustion of your alkanes. That's correct. Its molecular formula is C2H4. Well, that's incorrect. That's for ethene, right? That's for ethene. Why? Because the carbon hydrogen ratio is 1:2 over here, whereas in alkanes, you should remember, for ethane, it is the general formula is CnH2n plus 2. So it should be, carbon is 2, so H2n, 2n means 4, right? 2 times n That means 2 times 2 equals to 4. Plus 2 is going to give me 6. So it's going to be C2H6 for your ethane. But for ethene, it's going to be C2H4. So that is incorrect. Its atoms are joined together by ionic bonding. No, how can you expect ionic bonding in hydrocarbons? We're dealing with carbon-hydrogen bonds. That is simple, pure covalent bonds. Okay, some properties of a colorless liquid L are listed. It boils at 65 degrees Celsius. Okay, well, a little higher, not very high. At room temperature, if something boils at 65 at room temperature, what do you expect it to be? I think it's gonna be a liquid. I just think so, because the boiling point can only tell me after which temperature it's gonna be in vapor. But I need the melting point to get like either it's gonna be a solid or a liquid. Okay. Next thing, when added to water, 2 layers form which do not mix. That means it's insoluble in water. Right over here, insoluble in water. It cannot be an alcohol, because alcohols dissolve in water. Why? Because alcohols have an OH group, and this OH group is polar, so it's going to dissolve in water. Water dissolves polar things. Next, it does not react with sodium carbonate. With sodium carbonate, which group reacts? C double bond O, OH group reacts, and this group right here is a carboxylic acid functional group, which is going to react with your sodium carbonate, because with carbonates the acid react to produce carbon dioxide, salt in water. So over here, that means not a carboxylic acid, insoluble in water, so not an alcohol. It has no effect on bromine water. That means not an alkene, because all alkenes have effect on bromine water. If it's not alcohol, if it's not carboxylic acid, if it's not alkene, then that means it's going to be a alkane, or it can be an ester or something like that. Ethanol, no. Ethanol should dissolve in water. Hexane, yeah, it can be hexane. It can be. Hexene, it cannot be, because hexene should have effect on bromine water, because hexene has a double bond. It is 6 carbons with double bond between the 2 carbons. So 1, 2, 3, 4, 5, and 6. Next, ethanoic acid. It cannot be ethanoic acid, because ethanoic acid is going to react with sodium carbonate to give you sodium ethanoate, carbon dioxide, and water, because that's an acid, that's a carbonate. The fuel ethane, C2H6, burns in air to form carbon dioxide and water. We're going to combust our fuel and carbon dioxide, water. Which statement about burning ethane is correct? When 1 molecule of ethane burns, 1 molecule of water is formed. Well, that's not true. Why? Because you balance out this equation by, you need 1 molecule of ethane, right? If you need 1 molecule of ethane, you just cut this 2. You divide the entire equation by 2. So how are we going to divide the entire equation by 2? Well, that's going to be simple. What do? Divided by 2, divided by 2, divided by 2, divided by 2. This becomes 1. This becomes 3.5. This becomes 2. 1 times 2, 2 times 4, 2 1 times 2, 2 3 times 6. So if you have 1 molecule of ethane, well, you're going to form 3 molecules of water, right? So this is completely incorrect. The number of atoms at the end of the reaction is the same as at the start. The number of atoms. Now this is going to be a little tricky, because we are not dealing with the molecules here. We're dealing with the atoms. So let's first count the number of atoms. Forget this 2, right? Just in C2H6, how many atoms are there? You have 6 atoms of hydrogen, 2 atoms of carbon, right? So 2 plus 6 is going to give me 6, 7, 8. In total, 8 atoms over here. But you have 2 moles of it. So 2 times 8, you have 2 moles of it. So 2 times 8 is going to give me 2, 8 times 16 over here. Then you have O2. O2 means 2 atoms of oxygen that are covalently bonded with a double bond like this. So it means 7 times 2. Because you have 7 as the 7O222, like 7 of this thing. That's going to give me 14. 14 plus 16, I guess that's going to give me 14 plus 16, 10, that's 30. So 30 atoms, we're dealing with atoms, 30 atoms at the beginning of the equation And then over here, 1 atom of carbon, I'm going to forget this 4 right now, and 2 atoms of oxygen. In total 3 atoms. 3 times 4 is going to give me 12 over here. 2 atoms of hydrogen plus 1 atom is going to give me 3. 3 atoms of, in total, in 1 molecule of water we have 3 atoms. And then 3 multiplied by 6 is going to give me 3 6 times. 3 times 6 is 18. 18 atoms. 18 plus 12. 18 plus 12. 8, 9, 10, 30. After reaction, again I have 30 atoms. We're not dealing with molecules, remember. I'm counting the number of atoms in 1 molecule, and then I multiply it with the number of molecules I have. So 30 atoms at the start, 30 atoms at the end. Well, that makes my option B the correct answer. You have to count it. During the reaction, there's a decrease in the number of molecules. Decrease in the number of molecules. Let's just count. At the beginning, how many molecules do we have? 7 of O2 and 2 of your ethane. So 7, 8, 9. 9 molecules at the beginning. And at the end, how many? We have, let's remove this 4. We have 6 molecules of water and 4 of carbon dioxide. So 6, 7, 8, 9, 10. 10 molecules at the end. We're increasing. Initially, we had 9 molecules. After we've converted the reactants into the products, we have 10 molecules. So that means, what are we doing? We're increasing. So how come there be a decrease in the number of molecules, but there's an increase? The reaction is endothermic. Oh my god. If combustion happening, you're combusting in hydrocarbon, how can that be endothermic? Combustion reactions are always exothermic. They're always going to give out energy. Which reaction produces carbon dioxide? Addition of dilute nitric acid to copper carbonate. Well, that's going to produce, because whenever you have an acid, that's going to react with a carbonate. You know what you produce? You produce your salt plus water plus CO2. And in this reaction, if we write the equation, it's going to be HNO3 aqueous plus CuCO3. Copper carbonate is going to be a solid, is going to give me copper nitrate, which is going to be an aqueous plus water plus carbon dioxide. Water is going to be in liquid state, carbon dioxide is going to be in gas state. And you have to remember one thing, you have to balance it. You have to put it over here, and we're balanced. So that's the equation for reaction number 1, and that's the carbon dioxide gas we're producing. Heating zinc carbonate. Okay, you have to know the thermal stability of carbonates for this. Whenever you're going to heat group 2 carbonates, group 1 carbonates are extremely thermally stable. They don't decompose on heating, but the zinc carbonate is going to decompose on heating. And it's going to produce zinc oxide. The things it's going to produce is you have zinc carbonate, and then you heat it, and then you produce zinc oxide plus carbon dioxide. Got it? So, well, this is correct. This is correct. Combustion of methane. Yeah, again, that's correct. Why? Because when you're going to combust methane is C2H6, and then you add oxygen to it. You form carbon dioxide and your water. There's going to be a 2 here, and then there's going to be a 3 here. The equation's balanced, and successfully you've produced your carbon dioxide. So this one's also correct. 1, 2, 3, all are correct. Which type of covalent bond is found in both a molecule of methane and a molecule of ethane? Which type of covalent bond? Oh my god, let's draw methane and ethane. So for methane, we just need a carbon. For ethane, we need 2 carbons. For methane, we need 4 bonds like this. For ethane, we need 1, 2, 3, 4, 5, 6 bonds like this. Now remember, methane does not has a carbon-carbon single bond. Methane is just a carbon with 1, 2, 3, 4 hydrogens, whereas ethane is 2 carbons. So there is no carbon-carbon single bond in methane, but carbon-hydrogen bond is present in both. Which type of covalent bond is found in both? Okay, a single bond between 2 carbon atoms. That is incorrect. Methane does not has a single bond between the 2 carbon atoms. So this is your methane and this is your ethane. A single bond between a carbon atom and a hydrogen atom. Yeah, that's correct, because look, single bond between carbon hydrogen, Yeah, single bond between carbon hydrogen. There are 4 single bonds here and there's 6 single bonds here. So this statement seems correct. A double bond between 2 carbon atoms, we're dealing with alkanes, so we don't have carbon-carbon double bond because that's a sign of unsaturation that's present in alkenes. A double bond between carbon atom and hydrogen can never make the double bond because hydrogen can only make a single bond. It follows the duplet rule. It just needs one more electron, that's all. Coming on to paper 2, which is only going to be for the extended candidates. Methane and chlorine react to form chloromethane. Yeah, we know this. What's going to happen over here is that I'm going to tell you, you have your carbon and 4 hydrogens like this. And then you have your chlorine, which is going to be ClCl. What's going to happen is that you might think, how come chlorine getting added into this when you have no double bond? You're correct. But there's no addition happening over here. There is going to be a process going to happen. The name of the mechanism is going to be free radical. Just forget the free radical. Remember the substitution part. It's going to be a substitution process. How? This hydrogen is going to be substituted by a chlorine atom. And then what's going to happen next? If you allow the reaction to continue, this chlorine atom is then again going to come here, replace this hydrogen like this. Got it? So what do you form? You form dichloromethane, and this is a photochemical reaction. A very important word that's present in your syllabus. It says this is a photochemical reaction. That means it needs UV light, ultraviolet light, for it to continue, right? For the activation energy of this reaction to break the initial ClCl bond, you need the UV light. So remember, reactions like these, this is the only photochemical reaction in your syllabus. Condition, ultraviolet light. Type of reaction, substitution. 1 hydrogen being substituted by 1 chlorine at a time. Next, the structural formula of 2 hydrocarbons is shown. Which statement about the hydrocarbons is correct? Well, this one seems like a straight chain. This one seems like a branched one. Let's draw both. CH3, I'm going to first draw this one. CHHH, and then there is a CH2HH. Then again, there's a CH2HH. And then there is a CH3 like this. Good. This one, however, is CHHH. Then there is a CH. Then there is a CHHH, and then there's a CHH and H. You got to learn one thing. This carbon atom has this thing and this thing attached to it. So basically this thing is coming out of your straight chain. So this thing is a branch. And always remember that when you have the same number of carbon, like 4 carbons here, 4 carbon here, but this one is a branch, this one is a structural isomer of the other one. Branch hydrocarbons have a lower boiling point and melting point than the straight chain ones. Always remember, branched ones are always going to have, if the conditions are the same and they're like belong to the same homologous series, but the only difference is the structural isomer thing. The branched ones are gonna have the branched, you're gonna call it methyl propane, right? This thing is called methyl propane. Methyl propane has lower MPBP, melting point, boiling point, than your butane. Remember this thing. And then one other thing you got to remember. Why does this happen? Because I think that's going to be a lot of chemistry. That's not part of the syllabus. Why? But just remember this thing. Okay. Which statement is correct? They're both alkenes. How come they be alkenes? There's no carbon-carbon double bond. There's no unsaturation. They decolorize the aqueous bromine. That's a characteristic property of an alkene, not an alkane. Both are alkenes. Their structural isomer is correct. One is butane. All 4 carbons in straight chain. One is methyl propane. Why methyl propane? Because there's a methyl group on the second carbon. So you can also call it 2-methyl propane. But if you call it methyl propane, examiner is going to understand it's on the second carbon. Why? Because in a propane, you only have 3 carbons. You cannot attach the branch on the first carbon and the last. You know this thing, branching cannot happen at the terminal ends. So branching has to occur at the second carbon. And in propane, you only have 3 carbons. So examiner itself is going to know if you're going to say methyl propane,